Initial?
0.
0. Let me try it again. John starts from rest. He accelerates at 10 meters per second for 2 seconds. How fast is he going? Here we go. The initial?
0.
0. Acceleration? 10. Time? 10 times 2? 20. 20 meters per second. Totally unrealistic, but that's what you could do it with the equation without even thinking about it, right? You can just plug into that equation, you can get the right answer, and you don't even have to think about it. Which is nice sometimes, but I want you to be thinking as much as you can. All right, I got a couple more equations I want to show you. These are called the constant acceleration equations. Okay? That's what we're working out. These equations can be used anytime the acceleration is constant, which is always in this course. Let me write that first one down. V equals V0 plus AT. Any questions about that equation or what these things mean? Okay? Let's work out another equation now. Let's write this one as well. V average equals delta x over delta t. V average is delta x over delta t. Now, in this course, I'm going to write delta x as x final minus x initial. Are you getting used to this notation?
Yes.
Did I hear a grumble over here? It's okay? Delta is final minus initial. And for delta t, I know I'm going on a limb here. What should I put for delta t in this course?
T final minus T initial.
Very good. And what is t initial in this course? Very good. So I can just put t final, and that's just written as t. Okay so far? Jules, you look like you got a look on your face again.
No.
Is it okay? You're not trying to get your homework still, are you?
So does that mean that the distance
Distance.
equals the average velocity times the time plus x zero?
Wait, why did you define, so it's the beginning change? Wait, yeah, can you spend the x thing?
Yes. Delta means change,
Right,
and change means final minus initial.
okay.
It takes some getting used to.
So what's the final equation?
Okay, we haven't got to that yet. Okay, good question though. Lily, make sense? Grayson? Okay, now this is the tricky part. The average, if I say to you, Gracie, you just took 2 quizzes. You got 100 and an 80. Second one was a trick question, probably. What's your average?
100 minus 80 divided by 2.
10?
Plus 80.
100 plus 80 divided by 2. Very good. Which is what?
180. I don't know, whatever 180 divided by 2 is.
Now you got 100 and an 80. Then the average is 180 divided by 2, which is 90. Okay? Make sense? I'm going to do a similar trick here. V average is equal to V0 plus V divided by 2. Right?
Wait a minute. I understand.
Now that's true only because the acceleration is constant, but since it is, the average is simply the sum of the 2 divided by 2. Agreed?
I mean, like, I understand that, but what does that have to do with the...
Okay, that's a good question. I didn't say what it has to do with anything yet. But I'm trying to massage this formula into a form that's very usable. Okay? Now, I'm going to put this, I hope it's okay, I'm going to take this and jam it right in there. And here's what I get. V0 plus V over 2 equals x minus x0 over t.
So that's final.
No, that's not final. Final is going to be nice and easy. You see, excuse me. This V, is that V average or V instantaneous? Instantaneous.
When you multiply it, it's 2 now.
This V right here is not the average V, is it? It's the V at time t. It's at V, it's instantaneous. See, I'm trying to sneak this in there without using any calculus.
So, do you multiply by t now instead?
Okay, now I'm going to massage it a little bit further. That's right. What I really want to get is V. Or actually, in this case, I'm going to solve for, I think I'll solve this for X. So let's do this. Now, V initial plus V. But I already have an expression for V. V equals V0 plus AT, right? So I'm going to put V0 plus V, but for V I'm going to put V0 plus AT all over 2 equals. I'm sorry to do this to you, but I'm going to call that delta X again. Doesn't matter what I call it, X minus X here or delta X, does it? Still not done, but it's going to get done in a moment here.
So you're just
You see what I did? This right here is this. I've got 2 more steps of algebra.
Wait, do we have to go through this every time to get this equation?
No, we're going to get an equation we're going to use at the end.
Okay.
Just showing you. Human curiosity demands I show you where it came from. But most people will take the final equation and just use that.
Okay, so we are never gonna have to like cut out all these variables.
This process of using algebra is something we commonly do in physics, though. I wouldn't say it's...
Well, no, yeah, but like
But yeah, we
this
wouldn't do it.
specific, okay.
All right, bear with me till I get to the end here. Now, can I distribute the 2? Would anybody bark if I did that? Here we go. V0 over 2 plus V0 over 2 plus AT over 2 equals delta X over T. Is that okay?
Yeah, technically, I guess.
Would it just be 2VO?
That would just be.
Okay, well, Lori sees that these are the same. I'm going to put them together. 2V0 over 2 is just V0, isn't it? Plus AT over 2 equals delta X over T.
No, it's like.
Not that yet, are we?
One more step. Now can I multiply every term by
Wait,
T?
can you scroll up a little?
Scroll up. Now I'm going to multiply every term by T. Is that allowed?
Yes.
Here we go. V0t plus AT squared over 2 equals delta X. And most people don't write it like that. They put the 1/2 in front. And this is the final way you usually see it, or you'll see it in the book.
And when do you use this equation?
I'm going to explain in a second. Delta X equals V0t plus 1/2 AT squared, and that is number 2. Let's see how it works.
AT squared.
Yes. John starts from rest. He accelerates at 10 meters per second for 2 seconds. How far did he go? Let's try it. How far did he go asks what question? What is
Change distance.
delta X? That's right. How far did he go? Let's see, with no thinking. What's V0? 0. Plus 1/2. What's A? 10. What's T? 2 squared is 4. Times 10 is 40. Half of that is 20. 20 what?
Wait, but it's.
Meters. There, we figured out how far he went with no thinking.
Why did we put it in T?
zero.
Oh, thank you. 0 times anything is 0. His initial speed was 0.
So what is zero? It's the initial?
That was his initial speed. Started from rest. Okay, look for that word. Started from rest means V initial is 0. Now look, here's the thinking person's way to do it. John's starting speed was 0 and his final speed was 20. Therefore, his average speed was. John's starting speed was 0 and his, you're not lifting. His starting speed was 0 and his final speed was 20. Therefore, his average speed was 10. And if you average 10 meters per second for 2 seconds, you go 20 meters. That's the way a thinking person would do it. A non-thinking person would just plug into this formula and get the same answer. Which do you think I prefer? I don't care if you know about physics when you leave this class. I want you to learn how to think. Very few of you are ever going to go into a field that involves physics. Few of you will. But you're all going to go into fields that involve thinking. That's what we're going to focus on. Don't only rely on the equation, but the equations are nice, especially when you're tired and you don't feel like thinking. Does that ever happen? Okay. The A student will be able to think, use equations, and also use graphs. We're going to get to the graphs a little later. Okay. All right, let me catalog these equations. Equation number 1 on the formula sheet says V equals V0 plus AT. Here are the 5 kinematics variables, delta x, V0, V, A, and T. The second equation says delta x equals V0t plus 1/2 AT squared. The next one, I'm not going to derive for you, I'm going to tell you how I did it, but I'm just going to jump to the answer. Okay? I want to get you to do it. Imagine that I solved this for t and put that t in there and there. I could do it, couldn't I? And that would eliminate t from the equations, and I would get this. V squared equals V0 squared plus 2a delta x.
You're just completely taking out the t's.
I took the t's out. That's it. V0 squared plus 2ax. All right, John starts from rest and he accelerates at 10 meters per second for 2 seconds. How far did he go? V final? 20. 20 squared? 400. V initial? 0. Plus 2 times A. What's A? 10 times delta x. 400 divided by 20. Delta x equals 20. Same as before. Right?
So are these just 3 equations?
3 equations, yes. Now, I'm going to give you 5 equations. You can do everything with the first 2. You never need anything but the first 2. But the other ones are going to make your life easier if you have them. I could also eliminate other variables in these equations. I'll show you the results. Delta x equals b times t minus 1/2 at squared. And the final one, delta x equals 1/2 v initial plus v times t. These are the 5 kinematics equations. Only 2 of them are fundamental. The rest are derived from the first 2. So the first 2 are of importance.
What's the difference between the second one and the fourth one?
All right, the fourth one, this is V final, that's V initial, and this is plus, and this is minus. But other than that,